Welcome back, everybody. Today we're really going to get into titanium wire arc additive manufacturing,
Okay.
the safety considerations.
Yeah.
And we're going to be looking at some research that just came out of Oak Ridge National Laboratory.
Wow.
So this is very cutting edge.
Cutting edge.
As professionals in the metal additive manufacturing space,
Right.
you already know that titanium WAAM is really promising.
It is. Yeah.
Especially for these large-scale parts.
Yeah.
But it does come with some safety challenges.
Right.
And so this deep dive is really meant to just equip you with what you need to know to make sure you're implementing it safely
Yeah, that's great.
and effectively.
It's great to be here, and I think you're right.
Yeah.
You know, titanium WAAM, it really does offer some advantages, but you have to understand the safety side of it, too.
Yeah, let's just get right into it.
Let's get it.
So titanium,
Yeah.
often called the wonder metal,
I've heard that.
and for good reason,
Yeah.
right? I mean, just the strength to weight ratio,
Yeah.
the corrosion resistance,
Yeah.
the biocompatibility.
It's wild.
It's used in all these different industries.
So many.
I mean, from aerospace components
Yeah.
to medical implants.
Yeah.
I mean, it really is an impressive metal.
Yeah, and it's a big market, too, and it just keeps growing.
Right.
And, you know, traditional manufacturing,
Yeah.
like casting, you know, that has limitations.
Yeah. Especially for those larger parts.
Especially with those. Yeah.
That's where wire arc additive manufacturing comes in.
Yeah, that's right.
Right. It's a good solution to that.
Much more efficient, cost-effective way to build those large-scale titanium parts.
It is.
I mean, it really gives you design freedom
Absolutely.
and the ability for customization,
Totally.
which is so important, you know, in industries like aerospace
Yeah.
and defense,
For sure.
and a key advantage of WAAM, I
Mhm.
mean, especially the make-one process that we're going to focus on today,
Okay.
is that it uses standard welding hardware.
Right.
So that's good news for companies
Yeah.
that want to adopt additive manufacturing. It is?
Without overhauling their entire infrastructure.
Exactly.
Yeah.
Yeah.
Now let's talk about the elephant in the room.
Okay, what's that?
Safety.
Yeah.
I mean, titanium's reactivity with oxygen,
Right.
especially at those high temperatures.
Yeah.
I mean, that presents some really unique challenges
It does.
during the WAAM process.
It does. And that's because of the high oxygen entrainment temperature of titanium.
Right.
It means you need a really controlled environment.
Yeah.
And so that means an inert enclosure filled with argon gas
Right.
to keep any oxygen contamination from happening during the build.
And so that's essential for protecting the titanium.
Absolutely.
But it also introduces new safety considerations.
It does.
And we got to address those.
We do. And it's a little bit of a,
Yeah.
kind of a catch-22.
Right.
We're creating a confined space.
Right.
With potential hazards like asphyxiation.
Right.
Because the argon displaces the oxygen.
And then there's the titanium soot.
Yeah. Produced during the process,
Uh-huh.
which is highly pyrophoric.
It is.
So it can spontaneously ignite
That's right.
in the presence of air.
Uh-huh.
So that's a major fire and explosion hazard.
It is a big one, especially during cleaning and part removal.
Yeah. We're going to get into all that.
Okay, sounds good.
Okay. So we're dealing with some pretty serious stuff here.
Yeah.
Let's break down those hazards a little bit more.
Sure.
Starting with asphyxiation.
Yeah, so asphyxiation is a really big deal anytime you're working with these inert enclosures.
Right.
Argon itself isn't toxic,
Right.
but it displaces the oxygen.
Right.
And that can quickly become a dangerous situation.
Yeah.
And, it's colorless and odorless.
Right.
So you can't really tell.
Yeah, it's not like you can smell it.
Yeah, you can't
Right.
smell it. You can't see it.
Right.
So that's why monitoring is so important.
That's why the paper really emphasizes oxygen sensors and ventilation systems
Yeah.
as just absolutely critical safety measures.
The sensors are constantly monitoring the oxygen levels,
Uh-huh.
both inside and outside the enclosure.
That's right.
And the ventilation systems are just constantly removing that argon.
Yeah, keeping it from building up
Right.
to dangerous levels.
And there's a specific oxygen level
Yeah,
that they say you got to pay attention to.
19.5%.
19.5% oxygen.
Yeah.
That's your threshold for safe operation.
Yep. Anything below that,
Alarms are going off.
you need to be getting out of there.
Right.
Yeah, that's your red flag.
It's non-negotiable.
Yeah, you got to maintain that.
And then beyond the asphyxiation, you also have the whole confined space aspect
Right.
of working inside this enclosure.
Yeah, that's its own can of worms.
It is. I mean, you have limited access.
Yeah.
You
Yeah.
have the potential for it to be difficult to get out in an emergency.
Right.
And then there's the whole psychological impact.
Yeah, people don't like being in those enclosed spaces.
Right, of working in an enclosed space.
Mhm.
So how can we sort of mitigate those risks?
Well, I mean, the design of the enclosure itself is huge.
Yeah.
Making sure there's larger access doors
Right.
and adequate lighting and visibility.
You want to be able to see what you're doing.
Exactly. You want to be able to see, and you want to be able to get out.
Right.
So, even having things like emergency egress points built right into the design.
Yeah.
That's really important to think about from the beginning.
And then, of course, you have your standard confined space entry procedures.
Right.
You got to use a permit system.
Yeah.
You got to have a trained observer outside.
Right.
At all times.
All times.
You got to make sure that ventilation and communication systems are in place.
Yep. All that good stuff. All those procedures.
And now for the most significant hazard, I think, which is the titanium soot.
Right.
So we talked about it a little bit before, but this fine powder, it's highly pyrophoric.
It is.
I mean, it's a major fire and explosion risk.
Yeah.
And I was reading a report about an incident where they didn't handle the soot properly.
Oh, no.
And it almost led to this catastrophic fire.
Wow.
In a manufacturing facility.
Yeah, that's why it's so important to take it seriously.
Yeah, so how do you clean this stuff safely?
Right, so the paper outlines a 2-part cleaning process.
Okay.
To really minimize that risk of ignition.
Okay.
So the first stage actually happens while the part is still inside that inert enclosure.
Okay.
Under the argon.
So you're keeping the oxygen away from it.
Exactly. That's the goal.
At this point.
At that point, yeah.
But how do you clean it if it's still in there?
So they use these non-sparking tools.
Okay.
Like brass bristle brushes.
Okay.
To get the bulk of the soot off.
Right.
And then all that soot gets collected in a special container.
Okay.
Designed for safe storage and disposal.
So it doesn't ignite.
Right, because there's just very limited oxygen present.
So that's stage 1.
That's stage 1, yeah.
What about after the part is removed?
Right, because we can't keep it in there forever.
We can't keep it under argon forever.
Oh, so stage 2 happens after it's come out.
Okay.
And it's been exposed to the air.
Okay.
And that's where you got to be extra careful.
Yeah.
Operators have to wear, full PPE, respirator, the whole 9 yards.
So you got to make sure you have a really well-ventilated area.
Yes, absolutely.
With some good extraction systems in place.
For sure.
At this point.
Yeah, and for the final cleaning, instead of using brushes, they use a grounded vacuum cleaner. Specifically designed for combustible dust.
Oh, wow.
To remove any remaining residue.
So it's like a 2-part approach.
It is a 2-part approach.
So you're minimizing the risk throughout the whole cleaning process.
Exactly. And it's all about, you said it before, having a well-defined and carefully executed cleaning protocol.
Right.
That's critical when you're dealing with this stuff.
And then you get into the whole understanding of what causes fires and explosions, which is,
which is everything.
Kind of the foundation of this.
It is. And the paper actually, it uses the fire triangle and the explosion pentagon to kind of visually represent those factors.
And this is a good refresher, I think.
It is a good refresher.
Everyone.
Even if you're familiar with these concepts, it's good to see it again.
Right.
So the fire triangle reminds us that we need 3 things for a fire.
Yeah.
You need fuel, you need oxygen, and you need an ignition source.
Right.
So in this case, with titanium WAAM, our fuel is that titanium soot.
Right.
The air is providing our oxygen.
Of course.
And then any spark or source of heat
could be the problem.
Could be that ignition source, exactly.
And the explosion pentagon is taking that a step further.
It is, yeah.
By adding dispersion and confinement as factors.
Right. So it's not enough just to have those 3 things.
Right.
You also have to have the titanium soot dispersed.
Right. In a fine enough form.
Yeah. In a fine enough form that it can readily react with oxygen.
And be confined.
And be confined, yeah. In a space that allows the pressure to build up.
So it's all about recognizing those factors.
It is.
That contribute to a fire or explosion.
Absolutely.
Because once you understand that, then you can come up with those protocols.
Yeah, you can put the right safety protocols in place.
Okay, so let's get into those.
Okay.
Okay, so we've identified the hazards.
Yeah.
We understand the underlying principles of what contributes to these fires and explosions.
Yep.
So now let's get into some proactive measures.
Okay, yeah, let's talk solutions.
What can we do to further enhance safety?
Well, I mean, technology is a big part of it.
Okay.
Sensor technology is getting so much better.
Right.
And that means more sophisticated monitoring systems.
Yeah.
So you can have sensors that not only detect oxygen levels, but also monitor for those combustible particles in the air.
So you have an extra layer of protection there.
Exactly. Yeah. It's all about those layers.
Against those fires and explosions.
Right. And it's real-time monitoring, too. So you're not waiting for something to happen.
Right. And you're not just monitoring one thing.
Exactly. You're getting a full picture of what's going on.
So that's pretty cool.
Yeah. It's pretty amazing what they're doing with sensors these days.
What about enclosure design?
Yeah.
Are there any innovations there?
Oh, yeah. Definitely.
That could improve safety.
So they're working on new materials for these inert enclosures that are even more resistant to heat and wear.
Okay.
So, these advanced materials could really extend the lifespan of the enclosures.
Right.
Which is great because then you don't have to replace them as often.
Right. And that minimizes handling and maintenance.
Exactly, because all of that comes with its own risks.
So it's like a ripple effect.
Yeah, it's all connected.
And what about the human side of things, like operational protocols and training?
Right, because at the end of the day, you got to have people who know what they're doing.
And are well-equipped to handle these challenges.
Yeah, and that's why training programs are so important.
Right.
And they have to be specific to titanium WAAM.
Right.
I mean, you can't just give them general safety training.
Right.
They need to know the ins and outs of this process.
Yeah, the nuances of this specific process.
Exactly, and they need to know what to do in an emergency.
Right. Know how to use the PPE.
All of that stuff.
Right. So it's really about creating a culture of safety.
It is, yeah.
Where everyone understands the risks and they take responsibility for their actions.
Exactly. And that goes beyond just the people on the shop floor.
Right. It goes all the way up.
Yeah. Management supervisors.
They all play a role.
They have to be on board with the safety protocols, too.
Right. They're the ones implementing and enforcing those protocols.
Exactly. And they need to understand the hazards just as well as the operators.
And I'm curious about automation.
Yeah.
Can that play a role in minimizing human exposure?
That's for sure.
To the soot and other hazards?
Yeah. I mean, they're working on automated cleaning systems.
Wow.
Which would be amazing because then you're taking the human element out of that really dangerous part of the process.
Right.
And it not only makes it safer, but it also makes the cleaning process more efficient and consistent.
So it's like a win-win.
Exactly. Yeah. It's one of those things where technology is really helping us.
Right. It's not just about the cool new processes.
Yeah.
It's also about making those processes safer.
Absolutely.
So it seems like we're talking about a multifaceted approach here.
We are.
You got your advancements in technology. You got your comprehensive training programs. You got your robust safety protocols. And it sounds like a commitment to continuous improvement.
Right. Always looking for ways to make things better and safer.
This has been a really insightful deep dive.
It has been.
I mean, we've covered a lot of ground here.
Yeah.
We talked about titanium itself.
Yeah.
Then we got into the specific safety challenges of WAAM. And now we're talking about these mitigation strategies.
Yeah, it's been a journey.
It has been. So any final thoughts for our listeners?
Yeah, I would just say, safety is not something you can tack on at the end.
Right.
It has to be part of the whole process.
Right. Baked into the whole thing.
Yeah, from the very beginning when you're designing it.
Right.
Choosing your materials, all the way through to how you operate it and maintain it.
Right.
So stay informed, embrace innovation, and make safety a priority.
I think that's a great way to end this.
Yeah.
So to all our listeners out there, thank you for joining us.
Yeah, thanks for listening.
On this deep dive into titanium WAAM.
Yeah, it's been fun.
It has been fun. We hope you found this information valuable.
We hope so.
And until next time, stay safe and keep innovating.
Absolutely.